Okay, so now we have to start about the some other process that use air, rusting. Okay, so first I want to tell you rusting. There are two types of change: chemical change and physical change. And rusting is a chemical change. Okay, in next class you will study about the physical change and chemical change. But I am giving you a small idea or just little bit idea about the physical change and chemical change. See, physical change is reversible, means just like take example, if water change into ice, okay, and ice can be changed into water, so it is reversible, means it can be reverse, means water to ice, and we can again get water from the ice, means if we change water to ice we can again get water from the ice. So it is physical change, means reversible. Okay, it can be reversed. But in chemical change, just like when milk change into curd, okay, if milk change into curd, so it is not reversible, it is called irreversible. Curd cannot be changed into milk again. Okay, so it is called chemical change. So this is physical and this is chemical change. Okay, now coming to our topic, rusting. So anyone having idea about the rusting? Anyone having idea about the rusting? Okay, Srishti.
Hello, sir.
Yes.
Sir, when iron objects get covered with rust, then it is in the presence of moist air. It's called rusting.
Okay, just tell me, rusting is good for iron or bad for iron?
So bad for iron.
Okay, good. Now you can put your hands down. So it is a chemical change. And what happened when iron object, okay, if any iron object is left in a damp air means moist air, the air which contain water vapor, or we can say water. So, or water for a long time. So if suppose this is a iron metal, and it is left in water, okay, for a long time. Okay, just tell me, is water contains air? Water contains air, yes or no? And you have to just tell me one example also. How can you say that water contains air? Okay. Uh, Avika Asthana. Yes. Avika, just unmute yourself and answer. Okay. You can't unmute. Rudra.
Hello.
Yes, Rudra.
Good morning, sir.
Good morning.
Sir, water contains air by when the plants in the water do photosynthesis.
Yes, you can say that. And aquatic animals also living in water, they get oxygen, dissolve oxygen from the water. Okay. So we can say, yes, water contains air. So if iron is left in a water for a long time, so what happened? Water is also present along with oxygen also, because oxygen is a part of air. So oxygen is also present. Okay. So what happened after a long time? You will see that it gets covered with a reddish brown flaky substance. Means there is a reddish brown. Okay. Flaky substance. We can write like this. This is the any iron substance. Okay. And this is the flaky substance. And this flaky substance, what happened? It breaks iron slowly. Okay, after some time, what happened? This flaky substance removed. Okay, then this now other layer of flaky substance get covered with on iron. Then again, so what happened? Slowly and slowly it destroys the iron substance. Okay, and it is a chemical chain. So during the rusting of iron, the iron metal combined with oxygen in the air. Okay, because we all know that air is a oxygen is a part of air, and in the presence of water to form hydrated iron oxide, Okay, and this hydrogen oxide is called rust. So you can write the reaction for it, rusting reaction. So first we have to know that what is rusting. It is a chemical change, okay, and it occurs on the surface of iron when it is left in a moist air. Moist air means water and oxygen both should be present for the rusting. And after some time, what happens? It gets with a reddish brown flaky substance, and this flaky substance break the iron slowly and slowly. Okay. Now you can write the reaction. This Fe means iron. Okay, plus in the presence of oxygen and water vapor H2O, or we can say moisture. So it changes into Fe2O3 dot H2O, and this is called hydrated iron oxide, and this is rust. Okay, this is rust, hydrated iron oxide. The reaction is not important, but you can write it, hydrated iron oxide, and this is the rust. Okay. Okay, Rudra,
Good morning, sir.
good morning.
Sir, we cannot stop the rusting of iron.
Yes, we can stop. Okay.
So,
By see, in your houses, is there any iron gate?
yes, no, sir.
uh,
Yes, sir. Yes,
okay, windows are made, the window frame is made up of iron. So what do? You just paint it. Okay, every year or every 2 years you paint it now.
yes, sir.
So due to painting, what happened? The iron metal, this, suppose this is iron metal, and if you paint it, what happened? It is coated with a layer. Now oxygen and water does not directly react with the iron. So in this way we can prevent iron from rusting. And there is another method that is called galvanization. Okay, you will study in next class, and it is also a method to prevent the iron from rusting. Okay.
Yes, sir.
Okay, now you can put your hands down. So it is a chemical change. It is a slow process. Okay. It occurs in the presence of air, or we can say oxygen, because oxygen is a part of air, and presence of water. So rusting occurs in the presence of two things. First, oxygen, and second, water. Now, and we can say we can prevent the iron metal from rusting by painting it. Okay, and by the method of galvanization. Galvanization means what we do, we coat the iron metal with the zinc. Okay, zinc is the metal, so we coat the iron substance with the zinc layer. So what happened? It covered with another layer, so iron does not react directly with water and oxygen, so we can prevent it. Now, extraction of oxygen and other gases. Okay, so in hospitals, what happens if someone need oxygen? So what we do? We provide the oxygen only. We don't provide air. So what happens? First, we have to extract. Suppose this is a here air, in atmosphere air is present. Okay, and in air, what is present? Oxygen also, nitrogen also. Okay, and carbon dioxide also, water vapor also. Water vapor we can write H2O. Okay, dust particle also. So if we need oxygen, what we have to do? We have to extract, we have to separate oxygen from the air. If we need nitrogen, what we have to do? We have to separate the nitrogen from the air. If we need carbon dioxide for the fire extinguishers, so what we have to do? We have to first separate the carbon dioxide from the air. Okay, so this is called extraction of oxygen or other gases, extraction of gases from this air. So air is used for the industrial extraction for oxygen, nitrogen, and argon. So in the industrial process, what we do? We extract, we separate the oxygen, nitrogen, inert gases, carbon dioxide from the air. And in the first step, dust particle and water vapor and carbon dioxide are removed from the air. So one important thing you have to remember, in the extraction process, in the first step, what is removed? Water vapor, dust particles, carbon dioxide. So in first step of extraction, in First step of extraction. Carbon dioxide, water vapor, and dust particle is removed. Okay. After, from the remaining components, we remove what we desire: oxygen, nitrogen. Okay. The air is then liquefied. Liquefied means we reduce the volume. Okay. And we change its form, its state, from gaseous to liquid state. Now, and the air is liquefied at very, very low temperature. What is the temperature? Around minus 196 to minus 200 degrees Celsius. Okay. At this temperature, air is liquefied. Liquefied means change from gaseous state to liquid state. Oxygen, nitrogen, and argon are then separated by fraction distillation. Okay. So in the first step, we remove carbon dioxide, water vapor, and dust particle. Then oxygen, nitrogen, and argon. Oxygen, nitrogen, and argon. That is inert gas. Okay. Separated by fraction distillation. By fraction distillation. And this fraction distillation also used to separate the petroleum products also. Okay. So now we will discuss the exercise part today. First, don't raise hand. I will ask randomly. Don't raise your hand. Okay. Just put your hands down. Okay. I will ask randomly. Don't raise your hand. Okay. Vaishnavi Singh. Vaishnavi Singh.
Yes, sir. Good morning, sir.
Good morning. Percentage of oxygen in air.
The percentage of oxygen in air.
Yes.
Sir, 78%.
Okay. Jay Pandey. Jay Pandey. Yes. Unmute yourself. Okay. Farzin. Percentage of air. Yes. Farzin.
Good morning, sir.
Good morning.
Sir, percentage of oxygen in air is 21%.
And which component of air varies from place to place and height and due to height, altitude, we can say.
Sir, can you repeat the question?
Which component of air varies or is variable? We have discussed at the starting of the chapter. The percentage of any component varies from place to place at some height. Okay, just tell me, if we go to the heights, means just like a mountain, the percentage of oxygen will decrease
Decrease.
or okay, fine, good. Okay, Umang. Umang.
Hello.
Yes.
Good morning, sir.
Good morning. So which gas is necessary for photosynthesis process?
Sir, CO2.
CO2. CO2 means?
Sir, carbon dioxide.
Okay, fine. Anmol.
Yes, sir.
Rusting is physical or chemical change?
Physical.
Physical. Okay. Garima, rusting is physical or chemical change?
It's a chemical change.
Okay, good. So kindly note it, rusting is a chemical change. Okay, Anamika, give me one
Yes,
way
sir.
to prevent the rusting of iron. One way.
By painting.
Okay, good. Srishti,
Hello, sir.
oxygen, nitrogen, and argon separated by which method?
Sir, what?
Oxygen, nitrogen, and argon are separated by which method?
Sir, fractional distillation.
Okay, good. Avika, Avika, okay, Shreyans, Ashi,
Yes, sir.
okay. Which of the following component of air determines the climatic condition?
Sir, water vapor.
Water vapor. Okay, good. Aditya Kumar,
Good morning, sir.
good morning. So what is the process called when water vapor change into water?
Sir,
What is the process called when water vapor change into water?
vaporization.
Okay. Aradhya,
Hello.
yes. What is the process called?
Yes, sir. Good morning, sir. Sir, I think condensation.
I think no, it is correct. Okay, condensation. Okay, Garima,
Yes, sir.
uh, sorry, reverse. We can say reverse process of sublimation, or we can just tell me the process in which gas change directly into solid.
Sir, desublimation or deposition.
Okay, good. Manan, Manan Kumar Singh. Okay, it's not responding. Anamika,
Yes, sir.
in the process of condensation, what will be the correct on heating or on cooling?
On cooling.
Okay, good. Okay, Ansh Pratap Singh.
Yes, sir. Good morning, sir.
Good morning. Okay, so tell me the blue cobalt chloride paper turns in which color when it comes in contact with the water?
Sir, pink color.
Okay, good. Okay, so now you can put your hands down. We will meet in the next class. Okay, if you have any doubt in the second term topics, either this chapter or the last chapter for the third term, so you can text me. We will discuss in the next class, and our syllabus is completed. Okay, so we will keep discussion and revision. Okay, so for now, thank you everyone.